Okay, here we are back again. Now we're looking at Chapter 8, Factoring and Algebraic Expressions. Again, more opportunities for us to build on those skills and those techniques that we've been building on for the last 7 chapters. Now we're going to look at factoring algebraic expressions. In doing so, we'll look at multiplication of polynomials by monomials. We're going to look at multiplication of polynomials by binomials or binomials by binomials, division of polynomials, factoring polynomials, and factors of trinomials. So, although there's a lot of nomials in here, everything above a monomial is a polynomial. They're just limiting them to 2 or 3 terms, as you will see. So in the objectives, multiplying polynomials by binomials, and we've already been through this, okay? So we're going to take a look at, in each of those sections, achieving each of these objectives as we move through each type of polynomial. So Rule 1 tells us, under the multiplication of polynomials by binomials using whole numbers, when multiplying a polynomial by a monomial, there must be as many terms in the answer as there are in the polynomial. Okay, so let's look at this again. We will learn by working through the examples. So this example says we want 3x to be multiplied by the quantity inside of parentheses 4x plus 2. So in doing this, we're simply going to multiply the 3x times each of the terms inside of the parentheses. So we have 3x times 4x, and we're going to add that to 3x times 2, and we end up with 2 terms here, a polynomial 12x squared plus 6x. So as the rule said, you would have to end up with as many terms as you had in the polynomial. The sign of grouping, or the parenthesis in this case, tells us that each term within the group must be multiplied by that 3x outside of the parentheses. Another example here. Now you can see we've got 3 terms, the 3 green terms inside of the parentheses. Each of those will be multiplied by the 4 outside of the parentheses. So we have 4 times 2x squared plus 4 times 3x minus 4 times 4. So again, we end up with as many terms in the answer as there are in the polynomial. 8x squared, 12x minus 16. Okay, another one, a little more sophisticated here. You might be tempted to take the 3x squared plus 6 and multiply it by each of the terms in the parentheses, but that's not the case. You have to remember your rules, your orders of operation. The orders of operation tell us that the 6x is multiplied by each of the terms in the parentheses. The 2x is multiplied by each of the terms in the second set of parentheses. So in doing so, the 3x squared, we don't do anything with it yet. 6 times 2x becomes 6 times 2x squared. 18xy, because we've got an x and a y term. And then 12x. Then we move on to the second grouping. 2x times 3x gives us 6x squared. 2x times 4y, 8 times xy. And 2x times 3 gives us 6x. So now what we do is we reduce by combining the terms. So we're going to combine all the x squared terms to the x and the xy terms and the x terms. Okay, each of them can only be combined by the literal x, xy, and x squared. So in doing that, we're going to sum 3x squared to 12x squared to 6x squared, and we end up with 9x squared. Then 18xy plus 8xy gives us a negative, or a minus 10xy. And then finally, minus 12x plus 6 gives us a minus 6x. So now we have again, terms that end up being polynomials of the degree that we started with. In this example, we've got a fraction. Okay, so what we're going to do is simply multiply the 3a times each of the terms inside of the parentheses. So 3a times 2a, 3a times 3, minus 3a times 4a squared. We only multiply it by the numerator, divided by 3. So in doing so, the nice thing about that last term, the 3 over 3 cancels out, and I'm just left with 4a squared times a, which will gives me 4a cubed. So 3a, 2a gives us 6a squared. 3a times 3, 9a, minus 4a cubed. So moving the terms around, this is the common form. Put the term that has the highest number of exponent in the front and then reorganize. So since this is a negative, negative 4a cubed plus 6a squared plus 9a. In multiplying binomials by another binomial, we multiply each term in the multiplication by each term in the multiplier. Okay, the procedure then is similar to the procedure for the multiplication of two-digit numbers by two-digit numbers. So in this case, what you do is you say, okay, in essence, I'm going to take a times a, and then a times minus 2, and then the second term, 4 times a, and then 4 times minus 2. So when I do that, I get a squared minus 2a plus 4a minus 8. And again, the last step then is to combine the terms and simplify. So I have a squared plus 2a, because minus 2 plus 4 gives me a plus 2, and then minus 8. So we're just multiplying those through term by term. Okay, let's look at another example. 3a minus 2b multiplied by the value in the second parentheses, 4a minus 4b. So we take the first term, multiply it by the first term, take the second term, or the first term times the second term. Okay, then we do the second term times the first, second term times the second. So we end up with 3 times 4a gives us 12a squared. 3 times minus 4b gives us minus 4ab. 2b times 4a gives us minus 4 or 8ab, and then 2b and 4b gives us a minus and a minus, gives us a plus 8b squared. Combine the terms. In this case, it's just the two middle terms, both negatives. 12 and 8 gives us 20, and we have simplified our terms then to 12a squared minus 20ab plus b squared. In looking at division by polynomials, then, when dividing a polynomial by a monomial, each term then in the polynomial then is divided by the monomial. So in this case, we've got a polynomial in the numerator, a monomial in the denominator. In this case, I can break it up because it has a common denominator. 6x cubed divided by 3x, 12x squared divided by 3x, minus 3x divided by 3x. And this simplifies then. One of the x's here in the denominator will cancel out one of the x's in the numerator, leaving us x squared. 3 into 6 gives us 2. The same thing for the second term. 3 into 12 gives us 4, and we're left with 1x because of the cancellation. And then this 3x over 3x is simply 1. So it reduces fairly easily. Okay, your text goes through this long division process. You're never going to use that. If you want to look at it, go ahead and take a look at it. But for our purposes, we're just going to disregard their long division solution. Rule 8.2 then, in factoring polynomials, we find the prime factors of each term. Then we determine the prime factors common to all terms. The product of these factors then is called the greatest common factor. Divide the polynomial by that greatest common factor, and then finally rewrite the polynomial as the product of the greatest common factor and the quotient found in step 3. So let's take a look at an example. Consider the expression 6a squared plus 12a minus 18a cubed. Okay, so we're going to take each one of those terms individually and factor them just like we saw earlier in our textbook where we did factoring. So if we divide 2 into 6, we get 2 times 3, and a squared becomes a times a, but we can leave it as a squared. The second term, 12a, 2 goes into 12, 6, and then 2 goes into 6 another time, so we have 2 times 2 times 3 times a. And then finally, 18a cubed becomes 2 into 18, leaves us 9. 3 by 3 gives us our factors for 9, and a cubed, in essence, a times a times a. So these common factor of are, in this, the common factors are 2, 3, and a, or 6a. So that becomes our denominator, or our value that we're going to divide by in factoring this, this fractional relationship. So we go back to the original term, 6a squared plus 12a minus 18a cubed. We divide it by 6a, and we get a solution of a plus 2 minus 3a squared. Okay, the factors then of 6a squared, 12a minus 18a cubed then are 6a, which we came up with on the first step, and then a plus 2 minus 3a squared for the second step. So we can see here then our factored values, our greatest common factors then, if we multiply this through 6a times minus 3a squared plus a plus 2, we get back the expression that we started with. So just a stepwise solution for factoring polynomials. Factoring trinomials. A trinomial then is of the form x squared plus bx plus c, and can be factored into the expression of two values in parentheses x plus m or times x plus n, if we can find m and n such that m plus n gives us b and m times n gives us c. So this becomes one of these, again, that by inspection you learn how to do this by factoring through potential values for m and n. So if we consider the expression x squared plus 13x plus 42, the answer will be in this form, x plus m times x plus n. So if we go through a trial and error, we need to find two numbers whose sum is 13, but whose product is 42. So there's our 13, there's our 42. So if you look in your text, they give you an ordered progression here of choosing a couple of values that will sum to 13, but will have a product of 42. The last step then in your text shows that 7 plus 6 equals 13, 7 times 6 equals 42. So putting it in the form of x plus m times x plus n, we have x plus 7 and x plus 6 as our factored values for the trinomial x squared plus 13x plus 42. What if we only have two terms? In this case, x squared minus 36. Note that there's no middle term in this example and that the last term is negative. The only way the middle term can drop out is if the two numbers are equal. So in this case, the problem becomes very easy. The only two equal numbers is the products of, for minus 36, is 6 and minus 6. So it immediately becomes of the form x plus m times x plus n, and we end up with a positive and a negative value for our 36, because that will give us our negative 36. Factoring trinomials then, where we do have a middle term, this example shows a coefficient of x squared. We've got a 4 there where the form given to us said it was supposed to be x squared plus bx plus b. Well, in this case, we've got a coefficient of 4 on here. So what do we do with that 4? And it's a number other than 1. The coefficient of y squared in this case is 10. So we're looking for two numbers whose product is 4, because the first number is 4x squared, and two numbers whose product then is 10, the last term being 10y squared. The product of the means plus the product of the extremes must equal 13, which is that center term, the coefficient of that middle term. So if we take our values 1 plus 2 and 4 plus 5 and 8 plus 5, which will equal 13, we will end up with values for each of our terms 1, 2, 4, and 5. When we multiply this back out, we will get 4x squared plus 13xy plus 10y squared. So again, this was done by experimentation and or inspection to determine how we could come up with our means and our extremes to equal 13 and in the center term. In reality, not all trinomials are factorable using the methods that we developed then in this last section. In such cases, then, we must resort to another method of solution called the quadratic equation, and it becomes the most common way of solving. We'll explore the quadratic equation then in the next chapter 9.